The average radius of orbit for the Earth about the Sun is 1.495 times 10 to the 8 kilometers. The period is 3.6526 days. Okay, now we need to determine the constant to 4 significant digits. First, we have to take Kepler's third law, and we have to rearrange it so we have CS by itself. So CS is going to be radius cubed over period squared. Okay, now I need to change my distance from kilometers into meters. And this is quite easy because there's 1,000 meters in each kilometer. So I need to take that value and times by 1,000 or times by 10 to the 3. So this is just going to be 1.495 times 10 to the 11 meters. Okay, that one's not too difficult. Now this days. We have 3, 6, 5, 2, 6 days. I need to go into seconds. Okay, well I know that every day has 24 hours. And I know that every hour has 60 minutes times 60 seconds, or 3,600 seconds. So days cancel out, hours cancel out, I'm left with seconds. So I just need to take this 365.26 times 24 times 3,600. What I did not do is I did not memorize some conversion factor. I just used facts that I knew. Okay? So I need to quickly do that calculation. I realize I don't have it written down. 365.26 times 24 times 3,600. Okay, and I'm going to use all of these digits here. 3, 1, 5, 5, 8, 4, 6, 4 seconds. Okay, check my math there. Now it's a matter of just entering this piece of information into my formula. Okay, so CS is equal to R cubed, that's 1.495 times 10 to the 11 meters cubed, divided by the period. We just found the period to be 3,155,8,464 seconds, and this is squared. Okay, it said we needed to find this to 4 significant digits, and I think we're going to use this value. So my units are meters cubed per second squared. That's fine. Sometimes constants have funny things like that. To 4 significant digits. Okay, so 1.495 exponential 11. Now I take that number and I cube it. Then I divide by bracket 3,155,8,464. That's seconds, that last one. Yeah. And I square that number. Okay, 3.355, 1, 2, 3, 4 significant digits times 10 to the 18. So this is the constant that I'm going to use. Okay, now we're going to use that value. An asteroid has a period 8.1 times 10 to the 7 seconds. That should be times 10 to the 7. You have this written down already, though, on yours. What is the average radius of orbit? So we're going to use the formula R cubed equals CST squared. So R cubed equals, we're going to put in our C value. Actually, I'm going to cube root this right away. Cube root. Our C value we just found was 3.355 times 10 to the 18 meters cubed per second squared. Okay, and that is going to be times by the period squared, 8.1 times 10 to the 7 seconds all squared. Let's look at units. Here I have, seconds squared divided by seconds squared. I'm left with meters cubed, but I'm cube rooting it, so I'm just going to have meters, so that's good, that my radius is in meters. So now I need to enter this information in quite carefully, making sure I'm squaring at the right point, and then when I'm all done, I'm cube rooting. When you do all that, you should get 2.8 times 10 to the 11 meters. So give that a few tries on your calculator, and if you're having trouble, I can help you out.